Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
Hello guys, and welcome to this new lab session. Today we're gonna look at very exciting stuff, and we're gonna focus in particular on MNIST, an amazing database that was published years ago by Jan LeCon. Now, to be more specific, I would like to give you now an outline of what we will do very quickly. So we are on code lab as usual. Don't worry, all the code will be available in GitHub, and you will be able to reproduce all the results that I'm creating right now. So without further ado, I just would like to give you an idea of what we're gonna look at. Obviously, when we are training neural networks, and this is what we're going to do again today, we will need a cost function. So we're going to introduce two cost functions here, quadratic and cross entropy. Then we will focus on how to initialize properly your network, and we're going to look at strategies to initialize the weights of your neural net. Then we will get really at the core of how a neural network works by looking at what feed-forward calculations look like. We're going to also dive into back propagation and see how it can be speeded up using other techniques like, for instance, SGD and mini-batch. So what I will do now is I will try to be as quick as possible in commenting the code, while giving you enough details that hopefully will enable you to understand what's going on, and hopefully to reproduce the results and maybe run some tests on your own. So let's start with the first part, which is the declaration of and importing of standard libraries. So the first thing that I would like you to do is to prepare the notebook for the rest of the analysis. Now, the first thing is to import, to configure and to choose the right version of TensorFlow. As you probably know already, TensorFlow 2 is out, and I strongly recommend to use this version. The second thing that we will do is to import libraries that are going to be useful for the rest of the notebook. So the first set is standard libraries, like for instance JSON, random, random, we need only one importing, and then third parties like NumPy and Matplotlib. Obviously, when it comes to plotting graphs, there are several options like Seaborn, but my favorite one is PyPlot and Matplotlib in particular. There is also the option to specify a style that I like. It's called ggplot, and it will render our graphs so much better. Now, the second thing that you would like to do, as usual, is to import data. Importing data, in this case, it's again one line of code. We're going to use Keras because it's so convenient, guys, so convenient. So what we want to do now is to now that this cell is running, we want to work with the MNIST, and again, it's very simple. As you can see here, auto-completion actually does it all for you. So if you select Keras, then you select datasets, you have multiple options, and you get MNIST, and you load the data. Done. While the data is downloading, it is always judicious to have a look at what the labels in the data looks like. So the first thing that we do is to check out, have a quick look at the training data dimensionality. So what we're going to do, actually, I'm going to copy this so it's quicker. There we go. All right, so we have 60,000 samples at training time, or for the training set, and then 10,000 at test set. Very important detail. we're working with grayscale images. These are 28 by 28 pixel grayscale images. This is fair enough. Now the important thing now is to understand what is the distribution of the labels, and by labels I mean the categories of the training of the samples. So as you know, each training set and test set sample is associated with a label. MNIST is a database composed by images with handwritten digits, and each handwritten digit will have a label between 0 and 9, 0 and 10, I think. So what we're going to do is we're going to plot all the labels to understand what's their distribution. We can do that in a blink of an eye as usual. What we need to do is to import pandas, another library for data analysis. Very, very powerful, very convenient to learn. So what we do is we're going to create a data frame. A data frame is, I think, really about an Excel table, no more than that. So we're going to create this data frame. There is one capital letter. Then we're going to import data in it. We're going to look at the training set. So what we're going to do now is we're going to look inside. So this is a vector or a table with a column and two columns and 60,000 rows. This is very good because the training set is 60,000. So we have consistent results within our data frame. And what we want to do is look at the distribution. So what we need is just to plot an histogram, and we're going to be able to see actually two things. First of all, that the classes are 9. Actually, it's between 0 and 9, so we have 10 classes, and the distribution over these 10 classes is pretty much uniform. This is great. Because as we learned in previous sessions, if we want to use accuracy, we need to be sure that the distribution is uniform. Otherwise, we will have to change the measure of performances. So here it's all good, it's well balanced. So we can now go to the next step, which is data preparation. As you probably know already from, or remember already from the previous lab session, there are different ways in which your data can be represented. And one of them is like in this training set here and the test set, just to have one number for each training label. I'm going to show it again to you. So for instance, in sample 2, the label is 4. Now, this is good, and it's very compact, but in some cases, it's better to have a vectorized version of it, which means that in this case, we will have a vector of 10 elements, and we're gonna put to 0 all the elements but the one that is corresponding to the label. So in the previous case, it will be a vector of all zeros, and it will have a 1 in the 4th position. Now, how do we do that? Well, it's very simple. There is a function that we can import that essentially takes this number, creates a vector of 10, and then it puts a 1 in the right position within this array of zeros. And by the way, I commented all the code, so each line of code has a description and a comment, so that if there is something that is not clear or you don't understand in this session, you can always read the comments. So as I mentioned before, first of all, we need to unfold the vectors in training into the right shape. So for instance, in this case, within X train, we have both actually, sorry, in X-train we have a set of matrices 24 by 24, which means that we want to have matrices of this shape 1 times 7084. Very simple. You just reshape the vector and you have them in training input. Then we want to vectorize the labels. Again, this is very simple. The labels are in y underscore train. You call this function and you have the results in here in training results. Then you zip together the training inputs and the training results. So you put in the same structure the samples or the features and the labels. Now, another important thing is to do the same for the test set. So I'm not gonna walk you through this because it's the same operation, but it is important to note that we have to do it in this case for training and test. Then we get, let's say, in the most interesting part of the code, where we have to look at the cost functions. Again, in here we're going to use 2 cost functions, and I'm going to quickly introduce it. I have to change the type of cell to a text cell. We have 2 options here. Either we use a quadratic cost with a quadratic penalty term, or a cross entropy cost based on logarithm. And we're going to look in a minute at the different effects of them. And we are actually going to focus on the cross entropy because that's the one that we will use in this code, and it is commonly used. So don't worry about this part. We're going to get back to it. So the first thing that I would like to do is to give you an intuition of what the entropy, cross entropy cost does. And to do that, I don't need this, so I'm gonna define a range of numbers. If you don't know it, this is very practical. So np.arrange gives you the ability to create an array of floats. Let me give you an example. So in this case, I have 2 numbers, 0 and 1, and the step is 0.01, meaning that I want all the float numbers with increment 0.01 between 0 and 1. Fair enough. Now that I have a range, I can plot this range, and I can check out what the logarithm does to these numbers. Well, one interpretation of this transformation is that the numbers between 0 and 1 are, sorry, if the input is between 0 and 1, we are essentially expanding this range into a much broader range, and you can see here, but at 0 this function goes to infinity. Now what happens instead if we change this range? Let's say we put it 1000. Now what happens is that between 0 and 1000 the values are compressed. As you can see here, there is an awful lot of data here in this range between 0 and 7. So we're going to use this compression and expansion within our loss here to essentially change the way we look at errors. And the quadratic cost essentially implements the cross entropy cost implements this formula here. The quadratic cost is very simple. You just sum the squares of each errors. Again, it's a little bit more simple, so we're not going to look into that. All right, The last thing that I would like to do before stop and then look at the network architecture is to check the data. So you always need to be sure that your data looks fine, that everything from the number of channels, from the reordering of the pixels is coherent with what it should be. To do that, very simple. You want to create a number of subplots. So what you do is you essentially plot in a mosaic multiple images, let's say 9, and this is what you get. Okay, pyplot is not defined. Sorry guys, just need to define it. Okay, so I think we are all set. The data looks good. The labels, again, here look good. And the cross entropy function is defined. We have all the elements to then look at the next part, which is the network architecture.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.